Okay, hi everybody. Your professor that can't figure out technology in the classroom. Hopefully we get that worked out by Tuesday this next week. But here's a video in case you needed some stuff figured out here. All right, so the whole top part was for naming geometric figures. So what I planned on doing was giving you these parts to look at. So adding these marks and then using appropriate names. So a line is an endless amount of points going in two directions. All right, so there's a line, and it can be named various ways. It can be named with 2 points, and that's all you need. Even if there was a third point here, this would still be considered line AB. You could actually also call it line AC because all these 2 points is to determine the direction that it's going. Line CB, line BC, you can interchange all these letters any way you want. And then you need a line symbol, and that's what's important. So if I ask you for a line as a name in an answer, you would need the proper symbolism. But weirdly enough, you can also name lines with sometimes there's little cursive letters at the end of a line that doesn't represent a point. So therefore, that could be called line R, all right? And it's not a point on the line, it's just a little cursive letter next to it as its arbitrary name. Okay, so that's a little weird, but it does happen, and it will happen throughout this course. Not too bad. A ray has an endpoint. Think of a ray gun. Starting here, here is the gun. And then, okay, hold on. I don't know what that came up for, but technology again. So starting with point P and then going through Q forever. There is no 2 ways really to name this. You have to name this ray PQ with this ray symbol, and the first point, the starting point, is the one listed first, and then this is the ray symbol. So here is the name of this ray right there. That's how you would name it, and I think that's enough about that. Segments have 2 endpoints, so the segment symbol above this is nothing with arrows on it. All right, that means there are 2 endpoints, and they are A and B. If I put another point right here, this is still segment AB. All right, if you wanted to name segment AC, then that is the one that is only this length. All right, so there are only 2 options. You can flip the letters around. You cannot flip the letters around on array. This is actually even, well, this is definitely bad because this says starting at Q and going through P. And you're really not supposed to do this. That's pretty bad. You usually you start with the starting point no matter what the direction is, and then the second point is the one that it goes through. So we're not going to like that for arrays. Okay? Not just we, anyone wouldn't. And then the fourth thing is, what is an angle? An angle is an opening defined by 2 rays, really. All right, so this is the angle, and we can measure that in degrees. So what is important in naming an angle? That the vertex is where the 2 rays meet, is in the middle. So there are 2 options to name this, P to Q to R, and with an angle symbol in front, or R to Q to P. There are certain cases where you could just use the vertex, to name that angle. The only way you can use just the vertex to name an angle is if Q is the vertex for only one angle. See, you're going to get a lot of drawings, and they're actually below when we get into the math, where Q is here, and then we have RP, and then just put a Z here. You could not name any angle Q then. See, because Q is the vertex for this angle, and for this big angle. So what is angle Q? Which one are you talking about? That's why it's illegal to name that if this was drawn like it is. When I remove this, or if it was not there in the first place, angle Q is valid now because Q is only a vertex for one angle in this drawing. There is no other unique angle for this. So that is allowed. And sometimes you'll see an angle with a little number in there. That actually isn't the measure. That's just denoted as angle 1. So that's a 4th way an angle could be marked or named. Let's just say that. Okay, now kind of just through some arbitrary geometry questions here about what you need to do as far as the angle addition postulate. and then some things that you're going to need to know. So if you didn't pick this up and weren't able to complete this yourself because you weren't sure, then there's some things you need to be aware of. One thing you can assume in geometry is that a line is a line, that there is no bend in this. Now we know a full circle, if I go a full circle in the parking lot doing an illegal 360 in the snow per se, that your car ends up where it started as far as, where it's facing. So if you're in Walmart's parking lot and I start facing the W on the big Walmart and I do a rotation, one full rotation is a 360 degree. All right, so hopefully we all know that. So that's why I have this marked as 180 degrees, because this represents halfway around the world or halfway around a full circle. This is called a straight angle. So that means these two angles should add up to 180. And that's what's true about this, and that's how you would solve for what's missing. All right, so that's one thing we need to understand. Second thing we might need to understand is this angle is marked as a right angle. That means it is 90 degrees right here. And then this is called the angle addition postulate. If these two angles make up this angle here, then these two should add up to that measure. So these are a portion of 90 degrees each part. So these two should be able to add up to 90 degrees. So covering how you solve equations, what I always tell my students is, and this is something you definitely will teach as a grade school teacher, I would think, is how to solve an equation. My fourth grader, there's that sign again, love this, is doing solving equations in one way, shape, or form. And probably towards the end of the year, we'll do something maybe this bad, maybe not till fifth grade. But so anyway, the point is that you might have to solve something like this. So first of all, these two add up to 90. So how do I solve for x? Whatever you do to one side, you do to the other. So I want to subtract 14 so I don't see that anymore. And I want to get rid of these underlines here because I don't want you to think that's division. So now when I do rewrite this with this gone, 4x equals 90 minus 14, 80, 76. Then the opposite operation of multiplication is division. So I divide. Then x equals, I never was good at math, 4, 15, and then another 4, I think it's 19? Yeah, I think x equals 19. Good. All right, so you got that one. Excuse me, a little sick. I don't have this on my notes as far as what I'm going to give you for complete notes because it's just like that one we did 2 steps ago. But I will write the equation that's true and then focus on some other ones. These two angles equal that half circle, which is 180 degrees. Then you could solve, and we'll save you that, because it's redundant compared to that last example. All right. This is something called vertical angles. Can everyone say vertical angles? All right. So vertical angles are congruent. This is something that I'm just kind of throwing at you here, but it is from this chapter 1 if we did have a book. Vertical angles are angles that are made by two lines, and they are directly across from each other. Okay, so these are vertical angles, and no matter how I draw lines, like if I draw lines like this, and then I draw them real tight like this, like these angles are real small and these are real big. Well, you can see that these two angles look like they're the same measure. They're both very tiny. Actually, acute would be a name for that. And then these angles are really large. And actually, they are equal. Okay? Oh, that looks like a Teenage Mutant Ninja Turtle or something like that I just drew. Anyway, looks kind of weird. I don't know if anyone else sees it. That's just probably my weird